Good morning, physicists. Welcome to the second part of light, reflection and refraction. In the first part, we completed the reflection of light in the plane mirrors. Now we are moving on to second part, that is reflection of light in the spherical mirrors. First of all, there are some terms used in case of spherical mirrors like pole, center of curvature, radius of curvature, principal axis, principal focus, focal length, and linear aperture. This you can download from the notes. Now let's get to understand these terms. First of all, let me tell you that all the spherical mirrors are a part of a big sphere. That means the spherical mirror is a cut portion of a sphere. If we polish the inward surface, it becomes a convex mirror, and if we polish the outward surface, it becomes a concave mirror. The center of this sphere is the center of curvature for the concave lens or the convex lens. The portion from center to any point on the mirror is known as radius of curvature. Fine. If we divide the curvature of this lens or any of the lens and take its center, that is the point we call as pole. Pole is the central point of the mirror. The line joining the center of curvature and pole is called as principal axis. All the objects are kept at principal axis and their images can be traced accordingly. The distance between center and pole, the geometrical center of a distance between center and pole, that is the radius of curvature, is called principal focus. This is the point where all the light that is traveling parallel to each other are converged if we use concave mirror, and they appear to diverge and appear to come from a point that is focus of a convex mirror. Now keep in mind that when we are using a concave mirror, the center, the radius and the focus are on the left side. But if we are dealing with convex mirrors, then the principal focus and center and radius are on the right side. The diameter of the mirror, that is this length, is known as aperture. If the mirror is small, then the aperture will be small. If the mirror is slightly bigger, then the aperture will be bigger. That's all with the terminology used in this, in the case of mirrors. Now there's one more important topic that is slightly confusing. With the student, the sign convention. In the textbooks, the sign convention is given in a quite complicated way, but I'll make it simpler for you. You know that when there is an object and a mirror, then there is an image. The distance of the object from the mirror is known as u. U is the object distance, and the distance of the image formed from the mirror is known as v. So v is the image distance. So in every case, whether it's a lens or a mirror, you must keep in mind that u, that is the object distance, is always taken as negative. That means we will put a negative sign before the object distance. Suppose the question says object is placed 25 centimeters in front of the mirror. So you will take u is equal to minus 25. Right? If the mirror is concave, then its focal length will be taken as negative, and if the mirror is convex, then you will take the focal length as positive. All the objects are kept above, in front of the principal axis. So the object height will be taken as positive, and if the image is real and inverted, in inverted image the height is taken as negative, and a virtual image that is erect, the height is taken as positive. Important point is the mirror or the lens, whatever the optical device you are using, it is kept on the right side, and all the light that is incident on the device will be coming from the left side. This is a convention. The pole, as I've already told you, is the center of the mirror, and it plays the role of origin like in a graph. In a graph, the distances towards the right and upwards are taken as positive, and towards the left and downwards are taken as negative. Similarly, in this case also, all the distances are measured from pole. So distances which are measured on the right side will be positive, and distances measured from the left side will be negative. That's why the image distance, if the image is real, will be formed on the left side, the image distance will be negative. And if the image is formed on the right side behind the mirror, as in the case of virtual image, that image distance will be positive. But object is always kept on the left side. Therefore, the object distance will always be negative. The focal length of a concave mirror is on the left side. So focal length of concave mirror will be negative, but a focal length of the convex mirror is on the right side. It will be taken as positive. This you can see in the diagrams that this is a convex lens. The focus is on the right side, so it will be positive. Here, the focus is on the left side, it will be negative. The object is placed here. Distance is measured in the left direction, therefore negative. If the image is virtual and formed behind the mirror, then image will be here and the distance of the image will be positive. This table is also given in your textbook, which shows the position of the object, the position of the image, the size of the image relative to the object, and the nature of image. For this, we will discuss it through diagrams individually. Now, first case, when the object is placed at infinity. Infinity is a point which is very, very far and virtually unreachable. So, the lens or mirror we are using, as compared to that, the object placed at infinity will be huge, enormous. So, the light rays coming from the object will be considered parallel. And when parallel lines are coming and getting reflected from the mirror, they will be converged to a point called focus. So the image will be formed at focus. Keep in mind that image is formed where the light rays actually meet after reflection from the mirror, or they appear to meet. In this case, the parallel beam of light is converging at a point F called focus, and the image will be formed at focus. The image will be formed as principal focus or the focal plane. The image will be real, inverted, and extremely diminished in size. That means highly diminished. You must have noticed that when we form an image of the sun using a concave mirror, then the image size is just slightly bigger than a pinhead or a nail head. So as compared to the sun, the size of sun, it is almost point sized. Therefore, we say that the image formed is highly diminished. If the object is kept beyond C, that is pole, focus, center, and it is kept beyond center, then the convention is we take two rays traveling from the arrow. One will go straight parallel to the principal axis. After reflection from the mirror, it will pass through focus. The other ray will make like this oblique, which is passing through focus, and after reflection it will become parallel. So both these rays after reflection will meet at this point, and here the image will be formed. As you can see, the image is slightly smaller than the object and is formed between the point C and F. So we'll write that image is formed between principal focus and center of curvature. The image is real, inverted, and diminished. Real image is always formed when the light rays actually meet after reflection. So these are the two cases. Next, when the object is placed at center of curvature. When the object is at center of curvature, again we use two rays, one parallel to principal axis and after reflection passing through the focus, and one passing through the focus, and after reflection it will become parallel to the principal axis. In this case, the image is also formed at center of curvature. So the image distance and object distance, they are equal. So therefore, the size of image and the size of object are also equal. That means we say that image is formed at the center of curvature and the image size is as same as the object. Now if we move the object further closer to the mirror, then the image will move away from the mirror. This is a convention or a rule that as the object approaches the mirror, the image recedes away. That means if we bring the object closer to the mirror, the image formed will be further away. And if the object is further, the image formed will be near the mirror. In this case, the object now is placed between center of curvature and focus. Again, the same one parallel ray passing through focus, one passing through focus and becoming parallel. They will meet beyond C. So the image formed will be beyond the center of curvature. Now you can see that when the object distance is smaller and the image distance is larger, the image size is also bigger than the object. That means we will say that the image is real, inverted, and enlarged. Next is when the object is now brought at focus. Object is at focus. Both the rays passing through the focus will become parallel and they will go towards infinity. So we say that the object, when placed at focus, will produce an image which is at infinity and it will be highly magnified or highly enlarged. Remember the case when the object was at infinity, the image was at focus. Now the object is at focus and image is at infinity. They have changed their places. Now one more case is there when the object is moved further towards the mirror. Now object is between focus and pole. In this case, the rays after reflection will appear to diverge. Now if they are diverging and somebody is observing those rays, he will notice that the rays are appear to coming from a point behind the mirror. मिरर के पीछे से लाइट आ रही है, तो क्या दिखाई देगा? He will notice, he will perceive the image behind the mirror and the image will be enlarged. So these are the 6 cases of image formation in concave mirrors. Now there are several applications of concave mirrors, like they are using as a shaving mirror or a dressing mirror where you see your face slightly bigger, so it's easy to notice the makeup is complete and perfect. The reflector of a torchlight, the reflector of a headlight of vehicles, the dental mirror. You must have noticed that when you go to the dentist, he uses a spoon kind of thing to see the molars, and the image of the molar is slightly bigger because it is a concave mirror. In microscopes, reflecting type of microscopes and telescopes, and solar furnaces, where we use sunlight and the object to be heated at is kept at the focal point. So all the heat and light of the sun is converged at that point, and the temperature is so high that we can cook the food there. Now coming to convex mirrors. Convex mirrors are of opposite nature of the concave mirror. As the concave mirror was a diverging mirror, converging mirror, this convex mirror is a diverging mirror. In concave, we had real image also and virtual image also, but in convex, there is no real image, only virtual images are formed. And the virtual image formed in a convex mirror is always slightly smaller than the object. That is always formed behind the mirror. So there are two cases. One, when the object is placed at infinity, and the other, when object is placed at any point between the lens and the infinity. These are the ray diagrams to practice. Object is placed at any point between infinity and the pole. A ray going parallel to the principal axis, it will diverge and will appear to come from focus. And a ray which is directed towards the center of curvature will retrace its path. So both the rays are actually diverging, but they will appear to come from this point. So they are meeting not actually but virtually. Therefore, a virtual image is formed behind the mirror and it is smaller than the object. So the object, when placed at any point between infinity and pole in front of a convex mirror, then the image formed is behind the mirror. It is virtual, erect, and diminished or smaller than the object. When the object is placed at infinity, again the same case will be there. The image formed will be behind the mirror and at focus. And it is slightly, not slightly, but highly diminished. Now coming to the applications of convex mirrors. At the busy intersections, you must have noticed a circular mirror placed just where the roads are meeting. It is so because in this case, you can see whether an object is coming from the other side or not. At the blind intersections where you are not able to judge whether the car or a vehicle is coming from the other side, this mirror helps you to see whether somebody is coming from that, so you can act accordingly. In the departmental stores, where it is very difficult to keep an observation on every corner of the store, large convex mirrors are used which produce a smaller image, but they are covering almost full of the area. So we can see no shoplifting is being done or any problem is occurring in the store. Convex mirrors is used in ATM, which allow the user to see if someone is standing behind them or not. It is used in vehicles as a rear view mirror. Like this, you can see this is the rear view mirror and it is covering whole of the road, but the image formed will be smaller. That's why every rear view mirror has a message printed on it. The objects in the mirror are closer than they appear. Because the size is small, you may perceive that the vehicle coming from the back side is farther away, but this is not actually the case. It is much closer than you expect. As a reflector to reflect the sunlight. In movie making, we use these kind of reflectors so that the sunlight is scattered and the area to be filmed is illuminated well. Now come on the mirror formula or the mirror equation. F is the focal length, V is the image distance, and U is the object distance. 1 by f equals 1 by v plus 1 by u. This is the formula that you will use in practicing your numerical problems, where f is the focal length, v is the distance of the image from the pole, and u is the distance of the object from the pole. There's one more formula which is called magnification. Magnification is the ratio of the size of the image to the size of the object, or a negative ratio of image distance to the object distance. Now, relating to this magnification, there are some points to be kept in mind. If the final magnification carries a negative sign, that clearly shows or clearly tells you that the image formed is real. That means in case of real images, the magnification sign will be negative. And in case of virtual images, the magnification sign will be positive. Okay. Now, the value of the fraction, of this fraction, if the value of this fraction is greater than 1, that is like it is 5 by 3 or 3 by 2, that shows that the image is enlarged or of bigger size than the object. And if the value of that fraction is proper, that is, if it is less than 1, then it tells you that the image formed is smaller than the object. That means image is diminished. That's all with the mirrors. Now in the next part, we'll move on to refraction of light and lenses. Thank you.